left the world today. Right, what $200 billion could build. The question is whether anyone will build it. $126 a barrel, the highest oil price in 4 years because of one narrow strip of water. 20 million barrels per day stopped, 1/5 of all global oil going nowhere. Not just oil, fertilizer, plastics, pharmaceuticals. Everything the world makes uses something from this strait. I am standing at Fujairah Hemp, the last port before the strait. 180 ships are anchored behind me. None of them are moving. Every barrel from Saudi Arabia, UAE, Iraq, Kuwait, Qatar must exit through this single 33-kilometer gap. The bypass exists on paper. 32 kilometers of mountains stand between the Persian Gulf and open ocean. This is how you remove them. This mountain range is the only thing preventing the bypass, and it is one of the most hostile terrains on Earth. 2,087 meters of Hajar limestone. No roads, no infrastructure. The most rugged peninsula in the Arabian Gulf. Hajar limestone. Hard, fractured, full of cavities. The same rock that forms cliffs dropping into the sea. Panama Canal, 77 kilometers through flat jungle. This bypass, 32 kilometers through vertical mountains. Shorter, 10 times harder. No road reaches the survey points. Every piece of equipment flown in by helicopter. The survey alone takes 2 years. At 40 meters, the drill finds nothing. A cave system the size of a cathedral hidden inside the mountain. The mountain is hollow in places. The blast sequence must be redesigned entirely around the cave network. 3,000 seismic sensors deployed across the mountain. Every underground cavity mapped before a single blast is planned. A freshwater lens sits inside the mountain. Breach it during construction and the canal floods before it is finished. 3 possible routes. The southern route, 38 kilometers. The central route, 32 kilometers. The northern route, 28 kilometers, but through 2,000-meter peaks. Central route selected, 32 kilometers. Peak elevation, 650 meters. 3 lock systems required. 300 meters wide, 25 meters deep, 400 million cubic meters of rock to remove, 40 times the Panama Canal excavation. Before one blast, 180 kilometers of access road must be carved from vertical cliffs. The road is blasted from the cliff. Workers drill, the cliff face falls into the sea. A ledge wide enough for a truck appears. After every blast, workers clear by hand. No machine can reach these ledges yet. This is how roads begin in vertical mountains. Equipment arrives by sea. There is no other way. Every machine lifted ashore by crane onto a temporary jetty. 45-degree gradients, machines climbing ledges above the sea. One wrong move, the machine goes over the edge. 6 months, 180 kilometers of road carved from 2,000 meters of mountain before a single ton of canal excavation begins. 10,000 workers need water, food, shelter, and medical care, 200 kilometers from the nearest city. All of it built on this site. The nearest freshwater is 200 kilometers away. Workers build a desalination plant first. Everything else waits. The construction site needs 200 megawatts. No grid connection exists. Workers build the power station before they build the canal. 180 kilometers of mountain road complete. The construction army can now reach every point of the 32-kilometer canal route. The blast plan for this project is 4,000 pages long. Every cubic meter has been assigned a blast number, a charge size, and a sequence. The blast sequence is designed for 40,000 individual detonations, planned over 2 years before the first charge is placed. Every cave filled with grout before it is blasted. An unstable void underground becomes a controlled collapse. 800 vibration sensors embedded in the mountain. Every blast monitored. Excessive ground movement, construction stops immediately. The first blast is small. Cameras at 1,000 frames per second record how the limestone breaks. The model is calibrated. The real blasting can begin. Fragment size matters. Too large, the excavators cannot load it. Too small, dust fills the canyon and stops work for days. The cutoff wall goes in before the canal is dug, protecting the freshwater lens that keeps the construction alive. An unstable slope found directly above the planned route. 200,000 pounds of fractured rock above the workers. The route must move 80 meters south. Route moved 80 meters. New surveys, new blast pattern. 4 days lost. The first of many adaptations. The mountain forces. 40,000 blasts planned. Every one sequenced. The mountain does not know what is coming. The first production blast removes 50,000 tons of mountain. In 8 seconds, the canal begins to exist. 40 excavators in the cut simultaneously loading 100-ton dump trucks every 90 seconds. The mountain leaving on wheels. One truck every 30 seconds carrying 100 tons of mountain, 24 hours a day, 7 days a week. I am standing inside the canal. These walls were mountains 3 days ago. The cut is already 30 meters deep. 80 drill holes per blast face, 12 meters deep each. 960 meters of drilling for a single blast. Workers repeat this every day. AMFO, ammonium nitrate and fuel oil. The cheapest explosive that breaks the most rock. 40 tons per blast. Millisecond delay detonation. Each hole fires 17 milliseconds after the last. The rock fragments instead of shattering. Controlled, precise. The dust from one blast could close the site for 6 hours. Water cannons suppress it in 20 minutes. Workers move in immediately. Night shifts run continuously. The blasting stops at midnight. The excavation never does. The mountain moves by day and by night. 400 million cubic meters of rock must go somewhere. It goes into the sea. Workers are building new land with the old mountain, 100 meters deep. The machines at the bottom look like toys from the rim. Workers inside a canyon they are carving from a living mountain. At 120 meters, the mountain bleeds. Groundwater seeping through fractured limestone. Pump trucks deployed within the hour. A permanent dewatering network installed in the walls. 50,000 liters per hour pumped away. The cut stays dry. Work continues. The highest peak cannot be blasted from above. It is 650 meters tall. A tunnel boring machine will drive through its base instead. 8 meters per day through the hardest limestone in Arabia. The TBM boring the section the open cut cannot reach. Tunnel spoil removed on a conveyor behind the TBM. Every meter of tunnel, 3,500 tons of limestone carried out. A wall section becomes unstable overnight. 200 workers evacuated at 3 a.m. Engineers on site by 4 a.m. The slope redesigned by 8 a.m. Rock bolts installed in every meter of cut wall. 180,000 rock bolts holding the canyon walls open against the mountain's pressure. After the rock bolts, shotcrete seals the face. The mountain converted from fractured rock to stable engineered wall. Markets react to the bypass groundbreaking. Hormuz risk premium drops $8 per barrel. The canal saves money before it carries a single ship. 16 kilometers of open cut, halfway. 200 million cubic meters removed. 200 million still to go. The TBM breaks through. Tunnel meets open cut. The full canal route connected for the first time. Underground to open air. Full depth reached in the first section. 25 meters below sea level. 300 meters wide. Workers standing on the future canal floor. Maersk signs the first transit contract while the mountain is still being demolished. $50 billion in shipping committed before the first ship can pass. 250-meter walls, workers the size of ants against them. A canyon carved from a mountain in 3 years. 250 meters straight down, workers at the bottom, machines working beside them. The Panama Canal took 10 years to dig. This has taken 3. The last major blast, the main excavation complete. 400 million cubic meters removed. The canal route clear from sea to sea. The excavation complete. Workers who have spent 3 years removing a mountain stand at the bottom and celebrate. The blasted rock face becomes the outer form. Workers install the inner form. The canal wall poured between them. The canal wall must resist the pressure of 25 meters of water pushing outward. The rebarcade resists that force. Workers place every bar by hand. The mountain wall becomes concrete section by section. The raw rock hidden behind the permanent lining that will touch the sea. The concrete is waterproofed from behind. The mountain's groundwater pressing from outside. The membrane keeping it out. The canal floor. 1 meter of concrete, smooth enough for supertankers. Workers pouring the surface that will be underwater forever. 2 kilometers of finished canal. White concrete walls, smooth floor. The mountain converted into a waterway. Bollards, lights, markers. The canal is lining. Workers are making it navigable, turning concrete into a shipping lane. The lining advances from both ends simultaneously. The canal becoming navigable kilometer by kilometer. The tunnel sections lined with precast segments. The same method as metro tunnels, scaled for ships instead of trains. The canal can be emptied in 72 hours for maintenance. Pump stations built into the walls. An engineering requirement no previous canal has needed. 32 kilometers of lined canal. The waterway complete. What remains? The 3 lock systems that will raise and lower 300,000-ton ships. The lock basin, 400 meters long. The Eiffel Tower fits inside it lengthwise. Workers carving it from the rock at the canal entrance. The lock wall holds 400,000 cubic meters of water. The rebarcade for one wall weighs 8,000 tons. Workers place it bar by bar. 15,000 cubic meters in 60 hours. The biggest single pour of the project. The lock gates fabricated in South Korea. 65 meters wide, 30 meters tall, 3,000 tons each. Bigger than anything ever built for a canal. The lock gate sections arrive by ship. Too large for any road. Craned from the vessel at the canal mouth. Workers guide them to their launching platform. The gate is floated in. No crane large enough exists to lift it. Winches pull it millimeter by millimeter to its seat. The hydraulic system moves 3,000 tons against full water pressure. Workers install the rams that make the impossible lock gate swing. The lock fills and empties through underground culverts, not over the gate. A supertanker lock chamber fills in 12 minutes. The control building is built into the canal wall.
workers and computers managing every cubic meter of water movement. The second lock at the peak of the canal route, 650 meters above sea level. The wall's 45 meters tall, the engineering highest point of the project. The third lock completes the sequence. Persian Gulf, up, over, down, Arabian Sea. 3 lock chambers, 1 mountain crossed. A supertanker enters at sea level, rises 650 meters through 3 locks, descends, exits. The Hormuz Strait bypassed completely. The water is rising at 3 meters per minute. The lock chamber will be full in 12 minutes. 3 years of construction tested in 12 minutes of water. The canal needs an approach channel dredged on both sides. 15 kilometers of seabed removed to 28 meters depth on the Persian Gulf side. Dredged spoil dumped in a designated deep water disposal area. 50 million cubic meters of seabed material moved. The canal entrances need protection from sea swell. Workers build breakwaters from 15-ton rock armor units placed one by one from crane barges. Every approach buoy positioned to centimeter accuracy. Supertanker captains will follow this buoy line from 50 kilometers at sea. Divers inspect every meter of underwater wall. What workers built above the waterline checked by divers below it. Every canal needs a port on each end. Workers building the tug bays, fuel points, and control facilities that operate the waterway. The canal control tower radar coverage from 80 kilometers.